So in this problem, you are told that a wagon is to roll down a hill 50 meters diagonally. Hypotenuse of the hill is 50 meters long at 6 degrees down, and it's going to roll down the hill, it's going to hit level ground, and it's going to travel 40 meters on level ground. So we have 60 meters down the hill, 50, my bad. 50 meters down the hill, 40 meters down the straight. This is at 6 degrees, and we have a wagon. And what we're doing is we're seeing the Lone Ranger and Tonto. Do they have enough time to drop onto the wagon, take 5 seconds to grab the gold, and to jump out? So how long does it actually take them to travel 40 meters? Right, we're seeing if it takes more than 5 seconds to travel 40 meters, they will be okay. They can do their 5-second grab, they can get off before they crash. But if they're going to go 40 meters in 3-4 seconds, they're not going to have enough time to grab all the gold and jump off. So all we're doing is testing, well, how long does it take them to go from here to here, right? Is that more or less than 5 seconds? Can they get the gold and jump off before they crash? And so what that means is we need to know their sort of kinematics. We need to know their speed, their acceleration on this point. Really, the block accelerates down the hill, travels at constant velocity. So we really want to know this V. V final kind of sliding down the hill. We can just call it V. We need to know V. And one thing we can do is find, through conservation of energy, velocity as we exit the hill. Right, so mgh equals 1/2 mv squared. We can find v. Right, keep in mind that h is this vertical distance. So 50 sine 6. We can find v, but that's just velocity as we go down the hill. But when the Lone Ranger and Tonto jump onto the wagon actually slows down because of conservation of momentum. So the mass of the wagon times the velocity of the wagon, or this velocity right here, right? The velocity of the wagon as we hit the ramp, the flat, this momentum must be conserved. And so then we have the mass of the wagon plus the Lone Ranger and Tonto times v sort of final, right? When they drop down onto the wagon, we've just increased the mass of the wagon. And in order to conserve momentum, that means if mass goes up, the velocity has to go down proportionally, so that way they aren't just creating momentum. Momentum must be conserved here. And so we can use the mass of the wagon, the velocity of the wagon before they jump on, and then the mass of them all together, and we can find our v final. Right, the speed at which we are traveling 40 meters. And of course we know that velocity equals distance over time, or that time equals distance over velocity. So the time to travel 40 meters is 40 divided by v final, right? The distance we're covering is 40 meters. We're traveling at v final speed, which we found from momentum, which we found from kinetic energy. Right, so we're sort of layering in a few steps here. And if this time is more than 5 seconds, they're safe. If it's less than 5 seconds, they're going to crash.